Hello, everyone, and thank you for watching today's demo. My name is Corey Diatoma, and I'm an account representative here at Leostream. Today, we're being joined by Karen Gondoli, our CEO and Vice President of Product Management, who will share the technical aspects behind the Leostream platform with you guys in just a minute. In today's discussion and demonstration, we'll be focusing on a broader set of use cases revolving around engineers. These could be mechanical engineers in an automotive company, control systems engineers at an aerospace company, or electrical engineers at a semiconductor design company. What these engineers, or end users as we like to call them, all have in common is that they use complex applications to perform actions on large data sets. Maybe they are doing design work with CAD software or dynamic solutions with software such as Simulink as examples. If you're an enterprise IT specialist today, you'll see how you can use Leostream to build an IT solution for these engineers that helps your organization secure its data, improves your users' productivity, and simplifies your job of maintaining and monitoring the environment. If you're a solutions provider, you'll learn how you can leverage Leostream in your solutions to provide those benefits to your customers while also simplifying your task of lowering your bottom line. And with that brief introduction, I'm going to pass things off to Karen, who's going to take it away with an actual demo of the Leostream product.
Okay, thanks, Corey. So before I go into the demo, I want to do two things. I want to kind of elaborate a little bit more of the benefits of why you would want to go down this route. And then I'm going to show you an architecture diagram of Leostream to kind of get you grounded in the platform itself before I show you the demo of the connection broker. So you see here, I titled this slide Cloud Engineering for Your Engineering Cloud. There's really two things here that are going on. You as the IT organization or as a solutions provider, you're doing cloud engineering. You are building a cloud system, whether that be on-prem using virtualization, whether that be up in the public cloud, but you are building this system out of different components so that you can provide engineers a way to do their engineering in the cloud. And those engineers are then the end users. And why we see organizations doing this, it's really part of the digital transformation that they're doing. They want to make users productive from wherever those users want to work. And they do that by building an engineering cloud. So one of the reasons you would do this, obviously, it's something that's top of mind on everybody's agenda, is lowering costs. While you can leverage virtualization and cloud, as I mentioned, and using tools like Leostream, you can automate capacity and power state in those clouds so that you can lower your compute costs for cloud. And then also just lower, if you're thinking about on-prem resources, even just having a suite of hardware that you're using as a cloud, quote unquote, for customers. Even just being able to automate the power state of those helps you save on your electric bill. So there's all these different ways that you can really rack up cost savings by having these automation tools. Another way that actually ultimately lowers costs for the end users organizations, think about these large automotive companies or aerospace companies. They need to reduce the time to market for the solutions and the products that they're providing. And one of the best ways to do that is to ensure the productivity of their end users. Engineers are not cheap employees. You want to make sure that they're always productive. And you can do that by having anywhere access. So as the user moves around, they go home, they're on travel, they still have access to their engineering cloud. And you also do this by architecting the design through your cloud engineering so that it ensures disaster recovery, high availability, and all those other really resilient and redundant functionalities, so that, again, you can reduce time to market by keeping people productive. Well, that's kind of all in the cost side. If you look on the other side of the organization, there's everybody who's really concerned about security. Really, you want to make sure that your data is secure, particularly if you're an aerospace company that's doing DoD work, for example. By building an engineering cloud, you can keep data secure in a number of ways. One, there's actually the cloud storage for your data, obviously, but when you're talking about remote access, really what you want to look at is having a really robust platform like Leostream that allows you to design access control rules that give you really fine-grained control over who can actually log in, what can they connect to. That ultimately defines what data they have access to, And you want to secure that not just by these rules, but also through MFA. And you'll see that we have a number of different ways that you can enforce MFA for different types of users coming into a Leostream environment. Kind of on the flip side of the security, you want to make sure that you only give access to the right people, but then you also want to monitor to ensure that that's actually what's happening. And that's one of the real strengths of Leostream is the audit level tracking that we give you. So you see who's logging in, what did they do, are they idle, and you can look for outliers in behavior, catch things, people that are logging in when they shouldn't be, things like that. But the last thing, another reason that we really see people kind of embracing this whole concept of engineering in the cloud is because it allows you to attract talent. Right now, by having an engineering cloud that people can access from anywhere, that means you're really optimized for a global workforce, and that allows you to hire from a much larger pool than you might have locally to wherever you happen to be headquartered. All right, so with that all said, I did promise you a quick look at the Leostream architecture. It's something new I don't often do in these demos, but I feel like it'd be nice to get you grounded in what we actually have here. And this is it. So here, what you're going to see in the most of the demonstration is the Leostream connection broker, which is up there at the top right. It's really the brains of the operation. It's where you're going to define these access control rules and control who has access to the different resources that you're hosting. On those hosted resources, well, in Leostream speak, those are all desktops or servers. They're operating systems essentially that the user is going to connect into. And on those operating systems runs the Leostream agent. It's a small component, but very, very important, as it's what's providing the connection broker with all the information that you want to be able to monitor. Things like who logged in, did they disconnect, did they log out. It's also how you can perform some power control through the broker for physical machines. So small but mighty. So those are the components that would live kind of within your environment, whether that you're an MSP and you're hosting, like I said, hardware virtualization up in your cloud. You're going to host the broker and the desktops with the agents on them. And then you need a way for your users to access that. And that's done through the Leostream gateway. It really has two purposes. One is a login tunnel for the connection broker, and the other is for the desktop connection tunnel for the desktop. So the user can actually connect to the machine that you have locked away off the internet, because that's the last thing you want to do is put those desktops on the internet. So those are the three main components. And then over on the left, obviously, there's your end users and the clients that they're sitting at. You're going to see in this demo, the Leostream Web Client tends to be what we see a lot of people using lately. It's great because you don't have to install client software on a desktop. Really good for supporting BYOD initiatives. But you also can have zero clients, different thin clients, depending on how you want to architect your environment or what some of your security requirements may be. Maybe you have to have little tiny thin clients that are locked down and people can't install software on. So you use those thin clients to log into Leostream, just as an example. So to show this in action, let's share my screen and hide this little guy. Okay, so I mentioned you're going to see the web client. This is it. This is fully customizable. You can change the colors, the logos, this text here. And what you're going to see in upcoming releases is a whole new design for this. So this is a nice web client. Wait until you see the next one. I'm going to log in as an end user here. Let me show you an end user workflow first, and then we'll show you how I actually configured that within the connection broker. So I'm going to log in as me. Now, I happen to be offered a desktop that's running up in the cloud, and it's called my simulation server, but I'm actually going to end up doing a little CAD drawing on it. I'm going to go ahead and connect. So here what's happening is this actually is going to connect using the MechDyn TGX protocol. So in the background, the connection broker was asking the Leostream gateway in this environment to open up a port. My port is opened. Now I actually have my setup set so I can enter different credentials to log into the desktop. That's optional, however you want to do it. I could single sign in, or I can type in new credentials here. We see that use sometimes some engineering software you installed on the remote machine as a standard user, and all of your end users log in to the desktop with the same account, but the connection broker will let you know, okay, I'm using that machine right now, even though I'm logged into the desktop as a different user. So you still know, you have that visibility. So here I have my machine. I can do something like come in here and go to AutoCAD Online. And then I get logged in. I happen to have logged in before, so there I'm already logged in, and I can come and look at some samples because I don't actually know how to use AutoCAD, but I can show you. I can show you it rendering in the window here. It's initializing my data, and you can see it's nice and snappy. If only I knew how to do things, it would look even cooler. But you get this great performance from the TGX protocol. And because this is running up in the cloud, well, I can pick the instance size that I want that kind of optimizes that balance between cost for the instance size and the performance that the end user needs. So if someone's not doing AutoCAD or hardcore simulations, give them a smaller instance size, and that helps you save cost as well. So now let me show you what's going to go on here. I'm going to hit refresh, and I'm still logged in as me. And now you see this new invite button here. So I can actually come in here and invite another, oops, and invite another user. And I can, for security reasons, they have 10 minutes to connect. And if they don't, they aren't allowed to. Let me go ahead and send that. I do have an option to send an email just in case Mabel's not logged in right now. She'd get an email that would say, hey, you got 10 minutes, come join me. So let me go ahead and send that so I can see my invitation there. And now what I can do here is Mabel, just to show you, is she'll log in. She happens to be offered via a different policy in Leostream, a different set of access control rules. She's offered an on-prem simulation server. So here I'm actually in a hybrid environment. I've got some VMware and I've got some cloud. And then she's got the invitation that she can actually connect to. Now I've already got the TGX connection running here. So I am unable to have the two connections. Oops, I lost it. I'm unable to launch another connection because I'm sitting at the same client, but had Mabel been somewhere else, she could then connect to that by just clicking the connect. And then we would both be looking at that same session. And so this way we can collaborate on that CAD drawing, even though we're located maybe across the country. The other thing that you'll have to notice, this on-prem simulation server, it's also a TGX connection, and Mabel happens to have this configure button. There's this concept of user configurable parameters that you as the administrator can allow the end users to set. So in this case, Mabel's allowed to tweak the image quality for the connection, and maybe she wants to do that because she knows she's on a connection, a network connection that has less bandwidth or something. So it gives you a way to allow the end user to even tailor some of the performance that they get. All right, so how did all of that come to be? Here, same interface. Now I'm going to log in as the administrator. And so I'm going to see something completely different. And this is where you, as the admin, do all the setup. You're going to come into the setup section and hook a Leostream up to all of your third-party systems. And then we'll come to configuration and actually build these different VDI workflows. So first, let's look at setup. Obviously, I talked about security and authentication. So here in the authentication servers page and the MFA page, that's where you tell Leostream what types of authentication and how many of them does the user have to go through in order to access the environment. So you'll see I have a few examples here. I have Active Directory, it's pretty common. We also have NIS. For a lot of some engineering platforms we see actually they run on Linux. Linux is a beloved operating system for engineers. And some of those older environments actually need this NIS authentication for logins. So Leostream, it's very unique for us. We can actually authenticate users against a NIS environment as well. And then you see I have Google. Well, this is just integrated through the SAML protocol. So any identity provider that you use that supports the SAML protocol, you can register it with Leostream, and then you can use that as the front-end authenticator. And after the user actually passes that authentication, Google in this example would redirect me into the Leostream environment. That works great with Okta as well, Ping ID, again, anything that supports SAML. If you are using one of the username password methods like Active Directory or NIS, you can still do MFA by using one of two things. Leostream includes native support for Duo, using the Duo APIs, and then any other system that supports the Radius protocol. Here's another Okta Duo Ping ID. You install whatever kind of Radius agent that third party provides, and then you can create a Radius server inside of Leostream. use AD for or NIS for username password authentication, and then use your radius environment for the second factor. And that could be MFA, push, what have you. So lots of options on security. In my case, it was just username password, but plenty of other demos out there. You can see other MFA. For centers, well, I mentioned this is a hybrid environment. So here you can see in this particular broker, I'm actually managing quite a lot. I've got our on-premises VMware environment, AWS, and an Azure cloud. And then this Leostream center here, it's basically connecting to our Active Directory to inventory computer records out. So if you have big physical workstations that you want to manage access in Leostream, you can do that by joining them to your domain and managing them through an Active Directory center or an uncategorized desktop center. Any machine or server you have, you can install the Leostream agent on it, and it shows up in the uncategorized desktop center, and you can manage it that way. So many, many options. No matter how you want to build your engineering cloud, you can do it. Now, obviously, we talked about that gateway in that architecture. So once you build your gateway, you need to actually pair it up with your connection broker environment, and that's done on the Gateways tab here. So here you see this broker is running on-prem. This is in my VMware environment. This gateway is running up in AWS. You can see it here. So I've got running here just the gateway and my one desktop that we're connected to via TGX there. So that's the great thing about the Leostream architecture is the broker and the gateways are decoupled. So as you scale out your environment, as you add or move your cloud regions around, you just add gateways in the appropriate place, and your broker can stay put and just communicate with those gateways. So in the configuration section, the first thing I did here was I built some pools. In my case, I just created a pool based on centers. So I had a little organizational in there. Here's all my AWS machines. Here's all my Azure machines. And then within that pool, I created a subpool, which is everything that has, I happen to have a naming convention with TGX for my name. There's a number of different ways that you can create these pools. One of my personal favorites, which is kind of cool. If you have a Leostream agent installed on the machine, it reports back to the broker what display protocols are installed on that machine, so I can actually pool based on that. So if I know I want to have a pool of TGX machines, I can look for machines with an installed protocol of TGX. It's kind of nice. So in this particular demo, I'm using this cloud simulation server pool and then my on-prem, which the on-premises machines are basically my demo machine. So it's my naming convention again, and in this case, everything running Windows. So pools, ultimately, you're going to offer users machines from pools, but you need to tell the broker, how do I manage the connections to that, to the machines in that pool? So how you connect is defined by the protocol plan. So here you see I have a couple. I have one for the on-premise machine, premises machine, I should say. I'm using Mech9 TGX, and it's not going through a gateway because these are for users who actually already have network connection to, or network connectivity to that remote desktop. So they don't need to be tunneled through a gateway. And then you can set default parameters for the TGX connection. And here, as I mentioned, you have options to allow the users to modify some of the parameters for their best connection. And then here's my cloud TGX, which then goes through the AWS gateway. Now we talked about lowering costs in cloud, and obviously power. Is your machine still powered on? That's an important one. So here what I have for my cloud-based machines is a power control plan that automatically powers the machine off when the user is done. And you see in this form, it's broken into these sections. Has the user disconnected? Did they log out? Those are the events that are coming from the Leostream agent. So here what I'm saying is, well, if the user logs out, give them 30 minutes to log back in just in case, maybe they left a file on the machine, forgot to save their something, so they can wait 30 minutes. But if they're not back in 30 minutes, well, now I'm going to shut the machine down. Releasing, this is a more purposeful kind of action. I log out, okay, fine, I've logged out, maybe I want to come back in, but a release is something that you as the admin determine when that goes on. That's not end user controlled. And so because you have more control over when this happens, I tend to make this time frame a little bit less. I'm waiting 5 minutes to shut down the machine. I'm doing that because in this case, maybe as an admin, I want to release the machine from a particular user. but there's no reason for that machine to be shut down because I just want it available for somebody else. So I can go in and cancel the job. I have 5 minutes to cancel the job associated with shutting that machine down. So that's just a nice little admin trick that you can do using some of these delays. And how you determine when those releases happen, that's done through these release plans. Lots of different ways to model this workflow of when does the machine get released and therefore available for the next user. In some cases, you want a non-persistent workflow. All great in the cloud again as well, or any virtualization platform really. If you want to have a machine that somebody uses, and then when they're done with it, you want to destroy it, terminate it, delete it, whatever terminology you want to use. That's one of these non-persistent delete on logout plans. So here what I'm saying is when the user logs out, go ahead and release it to the pool. Again, you can delay this if you want. That then triggers these when desktop is released sections, both in the release plan and in the power control plan. So here I'm saying after it's released, well, here I'm going to wait 15 minutes before I delete it. As another example, disconnect on idle. Here's where I mentioned you can monitor idle time using the Leostream agent, and that works for Windows, Linux, and Mac as well. And you can do these different actions. And it's, again, the agent who's doing this. So after 5 minutes of idle time, the agent will disconnect the user's session based on this release plan, for example. So those are kind of bits and pieces of access control rules. And now you want to kind of bring them together in the overarching access control rule, which is what we call a policy. So here I have 2 policies. This one for remote users, and the bulk of the policies is done in pool assignments, because this is where you're going to say, okay, these are the pools the user has access to. Here's how many machines they can access in that pool, which pool it is. We talked about keeping users productive. There's this concept of backup pools. So if everything in the cloud simulation server pool fails the different checks, I can fail users over to another pool. Again, great way to make sure the users always have something to log into. Now, because for certain protocols, we do support that collaboration feature. Here in this part of the policy, I enabled it. You don't have to turn it on if you don't want your users to be able to collaborate for security reasons. Don't turn this on, but you can turn it on here. You can actually limit it to different groups of users. So that way, if you have teams of users working on projects, you can just allow users within that same team to collaborate. And you actually have the option of saying whether the users can send that email or not. That's not always there if you don't want it. And then finally, I set my plans over here. Oops, where's the cancel button? There it is. So before we talk about how those policies are assigned over to users, let's look at 2 things, locations and roles. A location is simply a group of clients, and this is useful for being able to tailor the end user experience and what they're offered based on where they come from. So in my case, I've got client locations set up by device type, which is a web browser. Maybe I'm doing that because I want to switch between, for example, the nice DCV HTML5 viewer if you're in a web browser, but the client-based DCV viewer if you're using Leostream Connect or a thin client. So there are different things you can do there. But you can also do this based on IP address. So if you want to have an IP range for your internal users, I can create a location for my internal users via IP address, or sitter should be in here somewhere. Can't find it quickly. And that way you can change, connect people to the on-premises resources when they're sitting at their desk, but connect them to the cloud if they're not sitting at their desk, kind of things like that. So I created a couple locations based on our client and the web browser there. And you'll see those come into play in a second. But first, I want to show you roles, because roles we don't talk about a lot, but they're very important for 2 reasons. One, you may have noticed here on my login, I had an open administrator view role link here, whereas Mabel does not. That's because of my role. My role gives me access to the Connection Broker Administrator portal. And the level of access it gives me is based on my role, which happens to be this one. So here I've given myself full access so I can log in and do everything, but you can actually change this to view only, no access. Some of the pages have custom options, so you can even come in and limit types of event or actions and information that the administrator can see. So that's using the role for delegated administration. The other thing is for end users and what they're allowed to do. So here I have a role that says we'll log the user in as a local user. So if you have Linux and you have local users defined on the machine instead of domain users, this is how you do it. It's quite straightforward. And then again, because we want to make sure only the appropriate users have the ability to collaborate or reboot their machines, we make that a role option so you can decide who gets to do what types of actions on their machines. And finally, that all comes together in assignments. So assignments is where you finally take those access control rules and indicate who gets which one. So here, this is done through my Active Directory in this case, and it's done by group membership. So I am a local administrator. I came in from a web browser. I'm not showing MFA again in this demo. And here's my role and my policy. Mabel fell through that role to the next one. She's an East Coast user, also coming in from a web browser. That's why she got a different policy. But again, these locations, I could have made this the IP address range or whatever I wanted it to be. Now, as added security, so here I've got 2 rows specified. If somebody who logs in doesn't match one of those group memberships, then they fall through to the default, and here I'm blocking access. So now, even if it's a user it's a valid user in your organization and they've managed to log into Leostream, they found your link and they logged in because they had valid credentials, they're gonna fall through to the default, and Leostream's gonna say, no, sorry, you're not allowed to log in. So you can block access even for your internal users using that functionality right there. The other thing I want to show before we close off is this collaborations page here. I mentioned about how Leostream is all about audit level logging and tracking. And I talk a lot about the log page on the system logs, and that's where you'll see the events coming from the agents and you'll see who's logged in and when. But there's all this other information on these resources pages. And the collaboration one in particular is showing you who's sending invitations out to other users and what desktops are they asking to collaborate on. When was it sent? Was it viewed or canceled? Did somebody connect? You see all this information here, so you always know which users are actually working together. And again, it's about looking for outliers potentially in users' behaviors or potential security problems. And the same is true on these other lists, all sorts of informations that really for your day 2 operations. As you've got this set up and users are logging in, you want to keep an eye on, okay, who's using this machine? When did they last connect? Do I need to upgrade the agent? Do I want to release this machine? Should I query the agent? Things like that. Really great IT tool just for simplifying, again, the day-to-day operations after this is all up and running. All right, I feel like I've talked for a long time, so I'm going to close off there and pass you back over to Corey to wrap us up.
Thank you, Karen. If you're interested in learning more about how the Leostream solution can help you with your either remote access or VDI workflows, you can contact us at sales@leostream.com. Or if you're interested in getting a free trial started, we do have those available as well. You can contact, again, sales@leostream.com. Thank you, everyone, for watching this demo.